Suppose we have these two variables, income as our X, which is our independent variable, and also expenditure as Y, which is our dependent variable. And then we want to find the best fit line for this data. So what we want is we want to find the straight line that has the intercept and also the slope coefficient. So what we can do is we can always use one of it is using Excel in order to get the intercept and also the slope coefficient. This is the data that we type in Excel, income and also expenditure, our X and also our Y. So what we can do here, we can go choose data here, okay, and then straight go to data analysis. So we have in the data analysis here. So you can always add this toolpath here by it adds in the Excel. So once we have this data analysis, we can click this. Okay, and then we choose regression. Okay, regression. Click OK. And then for the Y is our expenditure. So we click here and then we select our Y. Okay. And then our X, which is our income. Okay. Right, and then we can click OK. Right. So here it straight gives us the regression result. Okay, whereby you have the Anova table here. Okay, and you have the estimation output here, whereby this is the coefficient, right? And also this is in the coefficient, this is the intercept, and this is also the slope coefficient, whereby it's the coefficient of X. You can also get the estimation result using any other statistical software. So here in the notes is using SPSS, whereby you have here the coefficient. So this is the intercept 19.24 and this is the slope coefficient whereby it is 0.55. So any software such as Excel itself, SPSS, eViews, Stata, all will give you the same estimation when you do the regression. From the result, we have identified Y as our expenditure and X is our income. And then how do we set up the regression line or the straight line? So the straight line would be Y hat equals to 19.24. So this is the intercept and 0.5515. This is the slope coefficient. And you can always find these values from the estimation output. So from the Excel, we found 19.24 and 0.55. So what does this figure means? So when the weekly income is 0, so since if this is 0, you get Y hat equals to 19.24, meaning that when income is 0, the estimated weekly consumption is 19.24. And what does the 0.55 means? Means that if there for each additional 1 ringgit in the weekly household income, the expenditure on average will increase by 55 cents. So if you can remember, if you differentiate Y hat with respect to Y, you will get this 0.5515. So basically it is the changes in the average of y when x changes by 1 unit. Once you already know what is your B0 and B1, you can always put a value of x here in order to predict the average value of consumption. So if the income is 150 and you replace x with 150 and solve this, you'll get the estimated or predicted y is 101.97. Okay, so going back to the data in Excel, okay, we can go to data and we click data analysis. Okay, regression, and then the y data will be the expenditure. So I'm starting from the label itself. And also the x-axis will be the income. And then we have these labels. And then you can always click this one, line fit plots. And then, okay. Okay, so you see here, all right, so if I enlarge it, okay, so the x-axis is the income, the independent variable, okay, and the y is expenditure. So the blue dot here is the actual data, meaning it's just the scattergram between each of the pair. So if you go back to the data, if you plot each of the pair, when x equals to 100, what is y? When x equals to 150, what is y? So you get this blue dot here. But then you want to get the best fit line that represent the best the data. So we are using a simple linear regression model. So we are using straight line. So the orange dot here is the straight line. If you connect this is going to be a straight line, and it will cut at an intercept in y-axis, and also it has the slope values. And the orange dot here is the predicted or the estimated. If you go back to y-axis, is the predicted or estimated y, and the blue dot, if you go to the x-axis, it gives you the actual value of expenditure. So this is the predicted value, and this is the actual value of the expenditure at any given level of incomes. So from the result just now, we have the intercept is 19.24, so meaning that it will cut at 19.24, and the slope coefficient is 0.55, meaning the value of the slope is 0.55. So in SPSS, it will gives you the value of R, which is the simple correlation or correlation coefficient, which is 0.9548. So from the graph, the X dot here is just the pair between the income and also the expenditure. The red line here is the best fitted line, which is the sample regression line. This is the equation, y hat equals to intercept 19.24 plus the slope coefficient 0.55 x. So you will get R here in SPSS denoting the simple correlation, but in Excel it is referring to the multiple R, which is the simple correlation or correlation coefficient, the same value, which is 0.9548. And if you see the line here, okay, so still the orange dot, if you connect, it will give you the sample regression line.